we are beginning the new material in Chapter 1. Starting with the review of the rectangular coordinate system. Now, even though this is new material, you've seen a lot of this before, so I have a quick review. Go over some of the key ideas before we get into anything that might seem a little new to you. Of course, the rectangular coordinate system is credited by the discovery of René Descartes in his work. He was a sickly boy at a school that spent a lot of time in bed looking at the ceiling of the room that he was in, noticing a fly crawling along the ceiling and trying to figure out how could you determine the location of that fly. And from there, simple thoughts come great ideas. The X and Y coordinate system, you guys are familiar with the X and Y axis, the quadrants that it breaks into, the X axis being horizontal, the vertical axis being the Y axis, and of course the point of intersection of these two perpendicular lines being the origin. And of course we have ordered pairs, like the example that I have here, 2, 3, the X and the Y coordinate, sometimes known as the abscissa and the ordinate, kind of old school language. And of course, if I want to graph the point 2, -3, I start at the origin. The first number tells me right or left, over 2 units. The second number tells me up or down, negative down 3. And I put a point to represent that ordered pair 2, -3. Now, the distance formula defines the distance between points. For example, I already have one point graph. Let's say I put another point way over here at -3, 1, and I want to find this distance between those 2 points. I use the Pythagorean Theorem to figure out that distance, because I know that I can find this vertical distance and this horizontal distance for the legs, and then that means I can find the distance of the length of the hypotenuse, the distance between those 2 points. And the distance formula is derived, as you can see, from the Pythagorean Theorem, and this is one that you should have memorized. If you don't already have it, you need to put that one in the memory banks. And we're going to use that to find the distance between any 2 points on the coordinate plane. We also have the midpoint formula for finding the midpoint. Let's say we wanted to find the midpoint of the line that connects these 2 points. It'd be somewhere right around in here. And I want to find the actual coordinates of that. Then the midpoint formula is averaging the X values of the points that are the endpoints of the line segment, and the Y values, averaging those as well. So we're going to use these two, and this is another one that you should have memorized, to work some problems out over here. Find the distance between the point -1, 4 and 3, -6. This is just using the formula. So the distance is equal to the square root of the difference in the X values and the difference in the Y values, those quantities squared. Now, it doesn't matter if you call this x1, y1 and this x2, y2, just be consistent. Let's say I call this x1, y1 and this x2, y2. I substitute those values in, and I have, looks like 3 minus a -1 quantity squared, plus, looks like -6 minus 4 quantity squared. This is going to be the square root of 3 minus a -1 is 4 squared. -6 minus 4 is -10. That's squared. That's going to give me the square root of 16 plus 100, which is the square root of 116. Now, don't grab a calculator. I don't want a decimal approximation of this, unless, of course, the directions in the problem ask for a decimal approximation, but I would like it in simplest radical form. So I look at this and see if anything simplifies the square root of 116. I see a factor of 4. 4 goes into this 29 times, so I'm thinking that this is the square root of 4 times 29, or better, 2 square roots of 29. Now, we wanted to determine if the points A, B, and C form the vertices of a right triangle. I need to find 3 distances. I need to find AB, BC, and AC, and then determine which is the longest of those 3, or the greatest of those 3 distances, to see if I form a right triangle. I'll have to use the converse of the Pythagorean Theorem. So let's find AB. AB would be -2 minus a -6 squared plus -2 minus a -4 squared. So this is going to be the square root of That's 8 squared, 64. That's going to be 2 squared, that's 4. I don't need that much. And that's the square root of 68, which is better known as what? 2 square roots of 17. BC is the square root of, let's see, 0 minus 2 quantity squared plus 5 minus a negative 2 quantity squared. So that's going to be 4 plus 49. Looks like 49. That's positive 7 squared. The square root of 53. And AC, using those 2 points, that would be the square root of 0 minus a negative 6 quantity squared plus 5 minus a negative 2 quantity squared. And that's going to be 6. So I'm going to have the square root of 36 plus 49. Looks like the square root of 85 if I didn't mess up. Well, which one is longest? This one is. This is longer than the square root of 68. This is longer than the square root of 53. So if I have a right triangle, if indeed points A, B, and C are the vertices of a right triangle, say I don't want to graph it out because it might look like it's a right triangle and it turns out it's just slightly different. You can't always base it on the appearance no matter how well you graph. Use graph paper and so on. But I can use the converse of the Pythagorean theorem. So these would be the legs and this would be the hypotenuse if it is a right triangle. So I'm going to see if 2 square roots of 17 squared plus the square root of 53 squared is equal to the square root of 85 squared. Well, this is 68 because this is the square root of 68, and this is 53. Does that equal 85? Well, no, it does not. So, determine if the points, no, they do not form a right triangle. All right, and then the last example here is finding the midpoint. I threw some decimals in, but that's all right. We can still find the midpoint. I can do arithmetic with decimals. We average the x values, so that's negative 1.5 plus negative 8.7 squared, and then I average the y values, so that's negative 9 plus 4 squared. Well, negative 1.5 plus negative 1.8 is negative 10.2, so this is negative 10.2 divided by 2, and this, of course, is negative 5 divided by 2. Negative 10.2 divided by 2 is negative 5.1. And negative 5 divided by 2, I'll just write it as a decimal since the other one's already in decimal form. And I have the midpoint of the line segment that has those 2 points as its endpoints. Oh, before I sign off, I realized I made a mistake here. I was finding AC, and I had 5 minus a negative 2. It's actually a negative 4 here. So that's going to make that 81, and that's going to make that 117. So you think, hopefully everything's still going to work out right. Well, if I plug in the 117 here and the 117 here, that adds up to 121. It still does not equal 117. Careful with your arithmetic mistakes. I'd like to say that I did that on purpose just to keep you honest, but I just messed up.